Students, good morning. I am so happy to see you once again through this CETEL YouTube channel. My today's video session is development of expression for steady state molecular diffusion. Diffusion of A through non-diffusing B. Steady state. Molecular diffusion. Diffusion of A. Diffusion of compound A through non-diffusing. B. Before entering into derive this expression, the fundamental equation for steady state diffusion in a fluids at rest and in laminar flow. The equation is Na is equal to Na divided by Na plus Nb into dAb Pt divided by Rtz. Clear? Into ln Na divided by Na plus Nb minus Pa2 bar divided by Pt. Na divided by Na plus Nb minus Pa1 bar Pt. This is the fundamental equation for steady state diffusion, steady state molecular diffusion in fluids. This is the equation for steady state molecular diffusion in fluids at rest and in laminar flow. Laminar flow. Clear? This is the fundamental equation. From this main equation, I am going to derive the expression for steady state molecular diffusion, diffusion of A through non-diffusing B. For that, we have to derive the relationship between Na and Nb. Establishment of relationship between Na, flux of A and Nb. Too easy to understand, let us consider a simple example. That means air and ammonia. Absorption of air. Example is absorption of ammonia, component A, from air ammonia mixture. From air ammonia mixture. Using water as a solvent. See, this is the absorption column. From the top to bottom, water is being sprayed. From the top to bottom, water is being sprayed. So, flow direction of water is top to bottom. In the bottom, there is a provision to supply air and ammonia mixture. It is being entered at the bottom through a sparger. There, air and ammonia moved from bottom to top. During this movement, ammonia is being absorbed by water. There, ammonia is being absorbed by water. At the same time, air will not be absorbed by water. Ammonia A is being absorbed. Clear? Air will not be absorbed. Clear? That means flux Na is equal to constant. Flux Na is constant. Flux Nb is 0. Flux Nb is equal to 0. In order to understand this, let us consider a simple example. See this example. This is the flow of river water. Water flowing direction. This is water flowing direction. Assume that we have two kinds of fishes. Fish A, what is called ammonia. Fish B, what is called air. Two kinds of fishes. Clear? The fish A swims against the upstream. Fish A swims against the upstream. The swimming velocity of A is greater than that of the velocity of water in the downstream process. In the downstream direction. Velocity of A in upstream velocity of A is greater than that of downstream velocity of water. Hence, it moves very fastly. Point number 1. Point number 2. B is also diffusing in water. B is also diffusing in water. It diffuses at a velocity equal to velocity of water in the downstream direction. Listen carefully. A swims at a velocity which is greater than that of velocity of water. This is upstream, this is downstream. Its velocity is greater than this velocity. So it moves very fast. Listen, this is fish B. It is also diffuses in the upstream. The upstream velocity is exactly equal to velocity of water in downstream. So it is as such in stagnation. Listen, he is a fisherman. He is simply waiting in the bank of a river with a fishing net. He is very much interested about the rate of fish catch by his fishing net. So component A will be easily fished by the fisherman. Component B will not be catched by the fisherman because its velocity on both sides is equal. Clear? Right. Component A diffuses. Component A diffuses by virtue of its concentration gradient, which is equal to minus d PA bar divided by dz. Clear? Next, component B is also diffusing. Component A is also diffusing at a flux relative to average molar velocity. Clear? This flux Ja. So this is equal to minus dPb bar divided by dz. Clear? dz, which depends on the PA bar divided by dz. Differentiation of PB bar divided by dz. So Na is constant, Nb is equal to 0. I am going to adapt this information, this Na divided by Na plus Nb. Hence, Na divided by Na plus Nb is equal to 1. Is equal to 1. Now this equation becomes Na is equal to dAb into Pt divided by Rtz ln Pt minus Pa2 bar divided by Pt minus Pa1 bar. Clear? Clear? See, this is the location 1. Fishing net is the location 2. Here, say for example, 10 moles of A and 10 moles of B is being entered at the section 1. both will diffuse. The diffusing mobility of A is more than that of water. Hence, all the A will be catched by the fisherman. Clear? Say for example, out of 10 A's, 9 A's will be or 8 A's will be catched by the fisherman. Remaining only 2. Only 2. One. Similarly, only 2 fishes are there. At the same time, fish B, component B, its velocity is equal to velocity of downstream water. So all the B will be settled perfectly here. Here 10 number of A and 10 number of B means 10 divided by 20. That's why I have put this information in the middle. Here 10 number of A, only 2 number of 10 number of B, only 2 number of A. So 2 divided by 12, 10 divided by 12. Clear? For mole fraction or pressure fraction. Hence PB2 in the top position, PA2 in the bottom position. Okay, leave such things. PB1, PA1 plus PA1 bar plus PB1 bar is equal to total pressure. Similarly, PA2 bar plus PB2 bar is equal to total pressure. Both are same. Clear? From this information, I am in need of PB1 bar is equal to PT minus PA1 bar. I am going to simplify this equation. That's why I am made of PT minus PA1 bar. PT minus PA1 bar is equal to PB1 bar. Similarly, PB2 bar is equal to PT minus PA2 bar. Clear? One more information. Both are same. Hence, PA1 minus PA2. PA1 minus PA2. From this relationship, I am going to write PA1 minus PA2. PA1 bar minus PA2 bar is equal to PB2 bar minus PB1 bar. Clear? Very clear? Both are same. Okay. To simplify this equation, I am going to rewrite NA is equal to DAB into PT divided by RTZ into PA1 bar minus PA2 bar divided by again PA1 bar minus PA2 bar. This is other multiply and divided by PA1 bar minus PA2 bar. There is no changes in the value. This is for simplification of this equation. Again, ln PT minus PA2 bar. PT minus PA2 bar is equal to PB2 bar. Similarly, PT minus PA1 bar. PT minus PA1 bar is equal to PB1 bar. Clear? Instead of this one, PA1 bar minus PA2 bar, I am going to write PB2 bar minus P1 bar. So NA flux NA is equal to DAB into PT divided by RTZ into PA1 bar minus PA2 bar into ln into R into 1 divided by PA1 bar. Instead of PA1 bar minus PA2 bar, I am going to write PB2 bar minus PB1 bar. In denominator, it should become ln PB2 bar divided by PB1 bar. Clear? This is log mean difference of A. So this equation becomes DAB into PT divided by RTZ into PB mean bar to PA1 bar minus PA2 bar, where PB mean bar is equal to PB2 bar minus PB1 bar divided by ln PB2 bar divided by PB1 bar. That's all. See, this is the flux or rate equation. Flux or rate equation for diffusion of A through non-diffusing B. The equation is Na is equal to DAB PT divided by RTZ into PB mean bar into PA1 bar minus PA2 bar, where PB mean bar is equal to PB2 bar minus PB1 bar divided by logarithmic value of natural logarithmic value of PB2 bar divided by PB1 bar. That's all. Thank you.